Hello, afternoon. So we're gonna go over this concentrations worksheet together. By the end of this, you should be familiar with solving weight and volume problems, volume and volume problems, weight and weight problems, which you will then be assessed, and then quizzed on. So fair warning, there's gonna be a bit of algebra moving forward, but let's just dive in. So already you'll see that I highlighted these formulas that were given, formula given, and then these conversions, right? You should be familiar with these because they were shown in your notes. Oh, I'm sorry, I'm looking at the notes now. This one wasn't, but you'll see. That's going to be actually what we're going to be doing in the first three questions. So let me just dive in because it's actually very simple. And much easier than it appears. So it tells us 25% strength, weight and volume, I guess solution is going to equal how many milligrams per milliliter. So we have this formula here that tells us that a 25% solution, 25% solution is going to equal that same 25, that same percentage or that same X value over 100 milliliters. Right, this is grams. Now, grams. Let me make that more clear. That looks like a Y. Grams. Now, to get grams per milliliter, all we would have to do is divide this by 25, right? And the grams per milliliter would be 0.25 grams per milliliter. Now, you may think we're done, but our question is asking us for the answer in the form of milligrams, not grams. So all we would need to do is convert grams to milligrams. So if we have 0.25 grams, what is the equivalent of that in milligrams, right? We would just need to multiply this value by 1,000 because 1 gram is equal to 1,000 milligrams. So the same thing as multiplying by 1,000 is moving the decimal place forward 3 times. 1, 2, 3. We add a 0. We add a placeholder 0 here, making it 250 milligrams per milliliter. One more time. All right, and I'm gonna speed up a little bit here. So 4%, 4% strength solution is how many milligrams per milliliter, right? Based off everything we did here, it's going to be 0.4 grams per milliliter, right? Because, let me write that, let me zoom in. Because 4% is equal to 4 grams over milliliters, right? That's going to be, and then 4 divided by 100, 2, that's going to be 4. So it's going to be, but our answer needs to be in milligrams. So we would just need to multiply our value, which is going to be in the form of grams per milliliter, into milligrams, meaning we just move this 1, 2, 3, making our answer 40 milligrams per milliliter. Another caveat, bit of a nitpicky thing, but it's, something that I have to do, which is if you were to give me the answer just 250, I would take points off because I need the unit with it. So get in the habit of always doing that. Similar to like how if I were to ever ask a question involving money, the answer would always have to be in the form of dollars. Okay. Moving on. So now we have 0.8%. A 0.8% strength solution is going to be how many milligrams, right? So based off the pattern that we noticed here, all we really need to do is divide this by 100. That's going to be 1, 2. So that's going to be 0.008 grams per milliliter. And then if we multiply that by 1,000, that'll convert it from grams to milligrams, making it 8 milligrams per milliliter. Okay, moving forward to number 4. Now is where the algebra comes in. So our question reads, let me zoom out one more time. There we go. So suppose we have dextrose, and we have a 5% strength weight and volume solution, and 40 milliliters of the solution is given. How much active ingredient is given in milligrams? Right? I underlined that because let's go back up here. Our solution, or not our solution, our formula requires we work with grams. So ultimately, we're going to get the grams per milligram strength. So we would need to eventually basically translate it to milligrams. So let's just slap it into the formula. So 5%, that's going to be X, right? Because we're looking for how much active ingredient is in the given solution, because it's not giving us that, but it did give us the amount of the solution. So we have enough information to solve for X. And how we would do this is by going one step at a time. So first we would divide both sides by 100, right? And we're dividing by 100. We just move the decimal place back twice. So it turns our solution, our equation, into, let me just get rid of this percent sign. It turns our equation to 5/100 equals X over 40 milli. Let me get rid of the units altogether, just to make it a little less clutter in your face. So then what we do is we multiply both sides by 40. By doing that, we get rid of this. Oh, back here. By doing this, we get rid of this, right? So 0.5 times 40, that's going to be 2. So X is going to equal 2, right? And where X was, that's the gram. That's grams. So our answer is going to be 2. So how much active ingredient is given is 2 grams worth, right? But our answer wants to be in milligrams. So what we need to do is multiply 2 by 1,000 to convert it to milligrams. So our answer would be 2,000 milligrams. Let's go to number 5 real quick. And as I keep going, I'm going to be getting a little slightly faster. So we have a 0.2% strength solution, and we have 50 milligrams of the given solution, and we're looking for the active ingredient, right? But again, we're looking for it in milligrams. So we start by dividing both sides by 1,000. That's going to be 1, 2, 3. That's going to be 0.0002 being equal to x over 50. Now we multiply both sides by 50. Making our answer. I have my own sheet right here that I already completed it on. Making our answer 0.1 equals x. So our value is the amount of active ingredients is 0.1 grams. So we need to translate that to milligrams. So 1, 2, 3 is going to be 100 milligrams. Now, I think we're in for a bit of a shakeup, right? It's gonna throw us for a bit of a curveball. So let's say, for instance, you have 18.5 grams of glucose in a quarter liter. What is the strength percentage? So now it just gave us everything we needed to find the strength. So we have 18.5 grams of the active ingredient in there, and it's going to be a quarter liter. I'm really hoping you saw that, because we need 0.25 liters in milliliter form, right? How many milliliters are in a liter? 1,000. So that's going to be 1, 2, 3. So it's going to be 250 milliliters. And then we multiply that by 100. Now, I'm going to mention this to you, but you're at a point where you can use a calculator. So we just type this into a calculator, making our strength what? Making our strength 7.4%. Here, it's much more straightforward. There's a 2.4 grams. There is 2.4 grams of glucose in 150 milliliters. And what is the strength, right? We have just enough information to be able to just put it in the calculator and get to your answer. And your answer is going to be 1.6%. Number 8 is asking us how many grams of dextrose are required to prepare 3,000 milliliters of a 6% solution. We got our 6% solution. We don't have our grams. We have our liquid. And now we just solve for x. How we do that? We divide both sides by 100, making it, right, 0.06 equals x over 3,000. Now 0.06 times 3,000, that's going to be 180. So 180 grams are in this solution. Okay. I'm just checking how I'm doing on time. What is the strength of a solution of, I'm just going to call this U, if 120 milliliters contains 15 grams? It's worded a little differently, but same thing we've been doing, right? You just put that in the calculator and you will get 12.5%. Now let's take a look at number 10. How many grams of potassium permanganate should be used in compounding the following prescription? So we're looking for grams. So we're looking for, I'm going to go back up here. We're looking for X up here, as we've been doing for a majority of this. So we got our percentage, 0.02. We don't have grams. We have our liquid in the correct format too, because it's milliliters and not liters. So we don't need to convert anything, right? And then multiply that by 100 to get it turned into a percent. So we divide by 100. We divide by 100. Boom, boom. Even further back twice, turning that to 0.0002 equaling x over 250. Now we multiply both sides by 250. Which is going to be 0.05. Oh, that's wonderful, because it's asking it for us in grams, so we don't need to do any extra work. So our answer is going to be 0.05 grams. Right. And this is going to be the last problem where we will be dealing with weight and volume. So it's asking for how many grams of aminobenzoic acid should be used in preparing 8 fluid ounces of a 5% strength solution in 70% alcohol. Now this is super important because we're given our conversion formula right here. So we're given our fluid, but it's in fluid ounce form. But we have our conversion here. So what we need, all we would need to do to turn it into milliliters is to multiply 8 by 29.57. And that happens to be 236.56 milliliters. So we don't have our X and we have our strength. And then we use, and formula calls us to multiply by 100 at the end, right? So we do the same thing. Divide by 100, making it 0.05 and 2, right? 0.05 equals X over 236.56. Now we multiply both sides by 236.56. Right? And giving us, oh, and it wants the answer in grams, so we don't need to do any extra work. It's going to be 11.828 thousandths. also known as 11.828 thousandths grams. And that would be our answer. Now, when it comes to solving for volume and volume problems, the math does not change much. The only thing that changes is that we're dealing with two liquids instead of a solid and a liquid. So our question is asking us how many milliliters of liquid phenol should be used in compounding of the following prescription. So it's got a 4.5% strength, and the overall lotion has 320 milliliters of the liquid. And we're looking for how much liquid phenol is in there. So that's going to be up here. And then we just do what we've been doing. We divide both sides by 100. And 1, 2. It's going to be 0.045 equals x over 320. Then we multiply both sides by 320. Making our answer 14.4 equals x. That's going to be 14.4 milliliters. Making that our answer. So the whole of the solution is going to be at the bottom, and the milligrams of like the specific substance inside of the whatever, whether it's like a prescription, over the counter, whatever medicine it is, or just whatever solution it is going to be at the top. So now moving on to question 13. It asks us, what is the percentage strength of a solution of 900 grams of a liquid with a specific gravity of 600 thousandths in enough water to make 3,000 milliliters. Now, in the notes that I provided, at the very bottom, there's specific gravity formulas that show you exactly how to translate this density that was given to us into either mass or a volume. So we have this specific gravity here, which is going to be our density. And all we would need to do to turn this, because we're given the grams here and then the density, so we can use that. We can divide 300 by 0.06 to get our, I guess, it's hard to explain, to get our specific substance at the top. So what that looks like is this. Right? So we're going to have 900 divided by 0.600, which is going to be 1,500 milliliters. Now this value is what we place on top. Times 100. That's going to give us our answer. So you can slap this in there and you'll find that this percentage strength is 50%. We're gonna get more practice on this. Yep, in this problem right here. But first, now we're gonna go to weight problems. Same deal. The math doesn't change very much. It's just now we're dealing, instead of dealing with grams and milliliters over here, and then milliliters and milliliters over here, we got grams and grams. Weight on weight. So it asks us how many grams of phenol should be used to prepare 240 grams of a 5% solution. Let me zoom in. Right, 240. That's going to be the totality of it. So that's going to be at the bottom. Multiply that by 100. Already, I know we're doing this. Right, 1, 2 equals x over 240. Then we multiply both sides by 240. Making our answer 12 equals x. That'll be 12 grams. Now, we're being asked how many grams of a, let me zoom out so we can see the whole question. How many grams of a drug substance are required to make 120 milliliters of a 20% solution having a specific gravity of 1.15? So we're given our liquid, the totality of it in milliliters, sorry. So we need to use the specific gravity to convert it to grams so we can use our formula properly. So what we would need to do is, I'm going back to the notes to see that volume multiplied by the density is going to equal the mass. So that's going to be, our volume is going to be 120. Density is 1.15 hundredths. And that's going to be what? 138 grams. So now we have the totality. So we can start doing our math. 38 multiplied by 100. So we divide both sides by 100. 20%. That's going to be 0.2. 0.2 equals x over 138. Then we multiply both sides by 138, making our answer 27.6 grams. And now this one is all calculator based because we got our drug percentage. We got the whole solution. And we just multiply that by 100 to make it a percentage strength. So that would be 5%. If you were to put that in a calculator. Oh, I forgot to read the question. If 1,500 grams of a solution contains 75 grams of a drug substance, what is the strength? What is the percent strength of the solution, right? And this is how you would get it. Now for the last question. We're We finally made it. If 4 grams of boric acid is added to 100 milliliters of water, what is the strength solution of this? What is the strength of the solution? So 4 grams is added. What is the strength of the solution? So here, if the specific gravity is not given to you, as we did in 15, as we did in 13, you are to assume that the specific gravity is 1, making 1 milliliters of water 100 grams. Because to convert this into grams would be to multiply it by the specific density, but if the specific density is 1, it's going to remain 100. But over here, it also states that 104 grams of boric acid is added to 100 milliliters of water. So our final solution is not 100 grams, is going to be in fact 104 grams plus 4 grams, making our entire solution 104 grams. And then the amount of the solute that we're looking for in there is 4 grams. We multiply that by 100. That's going to get us 3.85%. So this one required just a little bit more critical thinking. That is going to be it. Thank you for staying with me.